I pick a point in the, think about it, I pick a point in the shape, x, y, z, right? I'm saying first, that point is constrained to be between 0 and 1. That puts me in the purple the purple region, right? Then I'm saying it has to be behind the vertical plane y equals 1 minus x. That forces y to be between 0 and 1 minus x. Now, you could have also gone the other direction. You could have equally well chosen here to say x is equal to 1 minus y, right? And you could have replaced this with, also you could do 0 less than or equal to z, less than or equal to 1, 0 less than or equal to x, less than or equal to 1 minus y. But then, when the last step, you get 0 less than y, less than or equal to 1 minus x minus z. That's another way you could set up the integral. Yeah. Yes, right. That would not be geometrically what's right. I'm not going to sugarcoat it. This is difficult. This will take you some work. You need to work some problems for yourself. Don't let me bully you into the answer. You need to come to the answer yourself on these. It's important to figure it out for yourself. I can explain it to you, but I can't understand it for you. You know? So there are great problems. There will be some problem in the book where he has like a specific integral, and then he'll say, set it up 6 different other ways. If you can do one of those problems with confidence, you understand the setup of the triple integral. Now, these bounds are relatively friendly. It gets worse. Okay. Yeah, I mean, unless you think you can hack through the inequalities. On occasion, I come across some problem where I'd rather do the inequalities. It's true, but all right. Let's look at another problem. I mean, we can take off tomorrow, but wouldn't you rather take off right before Thanksgiving break? Yes. So, all right. You guys in your class canceling rumors. Hilarious. All right, so here's an integral. Integral of, oh, we don't know that yet. Oh, fine, I'll do it though. So minus 1, well, yeah, minus 2 to 2, square root, minus the square root of 4 minus x squared to square root of 4 minus x squared, dy dx equals. Another example. Integrate minus 1 to 1. Integrate from 0 to 2, 0 to 3 of hyperbolic cosh of xy inverse hyperbolic tangent of, oh, not that one. Excuse me, what am I saying? E to the x squared plus y and sine of z. Dx, dy, dz. By the way, it takes me about 5 minutes to actually work this out. And when I do, I always make an arithmetic mistake. So I will spare you of it. There are examples like this in the notes with the gory details. If you want to, I can go through it. Would it be helpful? I see some nodding. me get this other stuff out of the... Are we done talking about this? This is the hard part, right? I think this is the mechanical part. I always have students come to me in Calc 3 and go, I understand integration, I just don't understand how to set up the bounds. No. That's the integration. That's the hard part. This is the easy part, right? I hope you can do this. But I don't know. I'm happy if people can do either, actually. Let's see here. So 1 minus x. So this integrates to what? Right, well, this would integrate to 2x plus 1/2 x squared, right? Evaluated from 0 to 1 minus y minus z. I know, right? Here's a cool trick. If you've just got a constant and you're integrating it, it's just the constant times the length of the integration region. So that 2 gives me a 2 minus 2y minus 2z. And then the other piece is just unpleasant. Plus 1/2 1 minus y minus z quantity squared, dy dz. Oh. Yes, probably. What is this? This is 1. Let me just write it out, otherwise I'll do something stupid. So that's 1 minus y minus z minus y plus y squared plus yz minus z plus yz plus z squared. What's that? But the trouble is there's a... wait a minute. How do I have... What? No. No. What happened here? I'm confused. I can't have an x outside the... I don't think my...
I think what they did is when they set up the bounds, they started with z, then went to y, then went to x.
Yeah, I think the differentials here are in the wrong order, right? Yeah, these don't make sense. So, I mean, we worked through this, right? This should be, what'd you say? Yeah, z, y, x. Thank you. Yeah. Whew, I was like, what on earth? Because I'm going to have a, I would have an x dependence after this integral, but I can't have an x in the answer. It should just be a number, Yes, sir. Yeah.
I mean, so you shouldn't have all 3 letters. I got a numeric answer. I just...
That's true. No, you're right. You're absolutely right. I should just have... That's a good point. There should only be 2 variables in the bounds. And annoyingly, I have erased the thing that would have explained it. What's that? You just did...
I just started with...
You did this one?
Yeah.
Yeah. Okay. I think that, see, now I've erased it. I can't fix it. Oh, well. So this would be integral from 0 to 1, integral from 0 to 1 minus x. And when we integrate with respect to z, we just multiply by that bound. So we get 2 plus x times 1 minus x minus y, dy dx, and so forth, all right? Is it time? Okay, well, good news. These problems I can solve in a minute. This is what?
0.
Not 0. No, this is the integral of dA over a circle of radius 2. Right? You've got minus 2 less than or equal to x less than or equal to 2. And you've got the square root of 4 minus x squared less than or equal to y less than or equal to the square root of 4 minus x squared. That is a circle of radius 2. The answer is 4 pi. Again, I'm assuming that the area of the circle is known. We will derive that very soon, okay? This one is what? We can use the trick I introduced last time because we have nice, wonderful, non-variable bounds. We love them. And when we do that, we have minus 1 to 1 sine z dz, integral from 0 to 2, blah. Well, anyway, the other two integrals, you know. This is kind of a modified version of that. See, this thing I can't factor, right? But it doesn't much matter. The point is that that's still a result. This is kind of like a partial factoring, but it's all I need because this is what? That's the integral of an odd function over a symmetric interval. It is 0. So look for that. If you see some onerously complicated integral, it's probably just me writing 0 in some kind of convoluted way to mess with you. Sorry about this. Thanks, folks.